Alright, so in this video we'll continue to talk about how to get the three things that we were trying to do in those previous sequences, which were finding the explicit formula, or first of all finding the common ratio, then the explicit formula, and then the sixth term. So for this one, obviously for 3, they give us the common ratio. They tell us that that's equal to -2. Difference now is they're giving us a random term. They're giving us the fourth term. So here's the format for our explicit formula. It's always whatever the nth term is, a sub n is equal to the first term times the common ratio to the n minus 1. So we know the common ratio this time. We know it's -2. The difference with this problem is we don't know what a sub 1 is. However, we do know what a sub 4 is because they're telling us here that it's 24. So we could say this. We could say 24 is equal to the first term times -2, and then because n in this case is 4, I'm going to put a 4 right there. So we'd have 4 minus 1. But of course, another way of saying 4 minus 1 would just be to say 3. So -2 to the third power. So if we continue this, we'd have 24 is equal to a sub 1 times -2 to the third. -2 times -2 times -2 is -8. And then we can solve that by dividing by -8. So we get a sub 1 is 24 divided by -8, which is -3. So our final answer here, the explicit formula is the first term, -3, times the common ratio to the n minus 1. There's our answer. And the other thing we were asked to do is find the sixth term. So a sub 6 will be -3 times -2 to the 6 minus 1. N is 6 right here, so 6 minus 1 is 5. That's equal to -3 times -2 to the fifth is -32. So -3 times -32 is +96. That would be the sixth term in that sequence right there. Alright, number 4 is a similar type of thing. This time we do have the first term, but the difference is we don't have the common ratio right here. So that's, you can see with a lot of these problems, the tendency is to kind of give you different parts of this formula, but not give you other parts, and you have to figure out what's missing. So we know a sub 4, so we can plug that in, and then we're going to have, instead of n minus 1, since we're finding a sub 4, n will be 4. Okay, let's plug in the other stuff we know. So we know that this equals -16. They're telling us up here that a sub 1 is equal to 2. We don't know what r is, but we do know that 4 minus 1 is 3. So let's solve this for r. Let's divide by 2 right here. So -16 divided by 2 is -8. So we want to solve for r by doing the opposite of cubing, which is taking the cube root. We kind of saw what the cube root of -8 was up here, because we did -2 to the third. That turned out to be -8. So this turns out to be -2. So r, once again, is -2. So now we can go back up here and find our explicit formula. We know that a sub 1, they just tell us up here, a sub 1 is 2. It's coming from right here. We just found out that r is -2, so there is our explicit formula. And the last thing we need to do is find the sixth term. So let's do that. So a sub 6 will be equal to the first term times -2 to the 6 minus 1. 6 minus 1 is 5. And this is very similar to the other problem. -2 to the fifth, once again, is -32. 2 times -32 is -64. That's what the sixth term is. Alright, here's the last example. It's kind of a fun problem. You walk into a room and shake hands with 5 people. Each of them shakes hands with 5 people, and each continues that process. If this happens 4 times, how many people are in the room? So this is actually a geometric sequence, and let's think about how to fill this in. I mean, you could draw this out, but just to see, you have 5. This is the first handshake. You have 5 people, and then each of these 5 people branches off. So there's the first person, there's the second person. Obviously, we don't want to have to draw all of that stuff, so it's easier to draw the picture. So this is happening 4 times, so we're being asked for the fourth term right here. The first term is going to be there are 5 handshakes, and let's keep this in mind. At the end, we're going to have to add you to this problem. So you're shaking 5 hands. We're not going to count you to start with. We'll just add 1 to the final answer. So 5 people are shaking hands in the first round, and then each one of these people is shaking 5 hands. So every time we're multiplying, you can see from this visual, each time each person is branching off into 5 more handshakes. So that means the common ratio is 5. And this is happening 4 times. So n is 4. So we raise it to the 4 minus 1. So let's see what happens. So we have 5 times 5 to the third power, which is 125. So 5 times 125, that's 625. But then remember, we have to add ourselves because we're in the room also shaking hands. So 625 plus 1 means that there would be 626 people in that room. Seems like a pretty big room. But that is the basics of how to use the explicit formula, how to find it on geometric sequences. In subsequent videos, we're going to talk about how to move into series, because we talk about that with arithmetic means. There's sequences and there's series. Now we're going to talk in the future about geometric series, so stay tuned for that.